So you have your 4 pieces of paper, okay? If you got two different colors, I would alternate them if I were you, okay? If you got 4 different colors, like it literally doesn't matter what order they're in, okay? I want my blue on the outside, so I'm going to switch my blue to the outside. And then I'm going to start lining them up like this. Now I've got them portrait, not landscape, right? I've got them portrait, and I've got about an inch or so separating the different colors. You see that? Everybody okay with this so far? Good, because nothing I did is hard. Okay, ready? I'm going to tuck under, God bless you, God bless you. I'm going to tuck under what I have and fold it so that I have an inch of colors all the way here. Does that make sense? My fold is right here. Yep, yours, it's probably too big though. It's probably too big in the spaces, because if you fold it where there's also an equal space, it'll be folded over on top of itself, and that's not okay. That's better. Yeah, absolutely. So tuck yours under instead of trying to fold it over. Tuck it under, like pull your pinkies underneath. Nope. Like this, like that. Does everybody have it? So I have mine done, so I'm going to take my stapler and I'm going to staple once toward the middle and once toward each end, like that. If you're afraid it's going to come apart, you could put 2 more staples here and here for 5 staples. It's probably a little excessive, but it's fine. There's absolutely no reason to go put a staple back there so that there's 9 staples. That's very excessive. But if you choose to do that, I will probably still love you. Probably. Okay? Aww. Now earlier they were trying to figure out if we could fold this in such a way where these 2 colors that are the same don't touch. You don't think so? You sure? Of course it did. Here we go. Of course it ran out of staples, because that's what's supposed to happen today, right? Okay. There you go. Yeah, you are absolutely correct. There's no way for us to fold it so that those 2 wouldn't be touching. Only way we could possibly do is cut. But even then, this is going to be the shortest and this one's going to be the longest. Or, yeah, we would have to lose a flap. Okay? Okay, are you ready to get started? I just want to make sure we have enough time. You ready? While you guys are waiting for the stapler, I don't know why I stopped at staple. I'm going to go ahead and write some things on this, on mine. I'm going to write the title, and I'm also going to turn it over on the back and write my name. Please don't write my name, write your own name. Okay? Any guesses about what we're talking about today? Oh my gosh, you guys are so smart. Please no throwing of the staplers. Or also please don't try to play basketball with the stapler. Yeah. It doesn't bounce as good as a basketball. Oh, no. Yeah, that's not good plans for tomorrow. Okay. Okay, you ready? So you have your name on the back and you have exponents written on the top flap, yes? Now, those of you who are still waiting for the stapler, it's okay. I'm trying to be patient with you, okay? Because it's not your fault other people can't staple fast. Or, I didn't mean that rudely. Okay. Wait, why are you having to push the staples down with your hand? Let me see it real fast. I don't know. I'm sorry. I don't know what to tell you. I'm going to pre-fold mine. Okay, I'm going to pre-fold mine. So see how I folded that top flap up, and then I'm going to fold the next flap up, and the next flap, and the next flap. Go ahead and, if you have already stapled yours, let's go ahead and pre-fold all of our pages. Please. Yeah, the whole purpose of a stapler is so that you're not having to bend metal with your own fingers.
Well, I meant like if you open up the stapler and like put the staples that haven't been stapled yet in there.
So the stapler is just being a jerk.
Yeah.
Oh, great. Nobody wants a jerk stapler. Okay, are we pre-folded? Hopefully. Okay, so I'm going to start writing on the first flap. It looks like almost everybody's almost caught up with me. By the time I get this done, you should be able to be caught up with me, okay? The first rule that we're going to talk about today is product of powers. Now, you may not know the name of the rule, but I'm betting money, not money, because that would be wrong. I'm just betting, just in general, that you know this rule. A to the m times a to the n. If I'm multiplying like bases, what do I do with the exponents? Yeah, I add them. So I get a to the m plus n. Okay? Now, did you know that was called product of powers? No, but do you know it now, right? You already know the rule. Now we can associate the name of the rule with the rule. God bless you. Okay? Now, the whole purpose of us pre-folding is now I have this small little area right here. I can actually take some notes. God bless you. Okay? So let's go ahead and take some notes in this area right here. What if I said x squared times x to the third? What does that equal? Well, following our product of powers rule, absolutely should be x to the fifth, shouldn't it? Now, can I try to trick you? Okay, what about 3 to the fourth times 3 to the ninth? Do I mess with the base at all? 3 to the 13th. Now, is 3 to the 13th actually something I can get a value for? Like I can plug 3 to the 13th in my calculator and hit enter, right? That's not the purpose of this problem. The purpose of this problem is, do we know the product of powers rule? Which is, leave the base alone, add the exponents. Does that make sense? Okay. What about this example? X to the 3 halves times x to the 4 halves. What if we have that as our example? What do we do there? Oh, the same thing? Okay, how do you add 3 halves and 4 halves? What do you get? 7 halves? Okay. Any questions about product of powers? Okay. What about power of powers? The next rule that we're going to talk about is power of powers. If I have a to the m raised to the n power, what do I do with those exponents? I do. A to the m times n. Okay? So go ahead and fold up that page and let's take some notes in this area right here. Okay? X squared to the third power. What do we get? X to the sixth. Yeah, that's exactly right. X to the sixth. Because my rule says if I have a power raised to a power, I multiply those numbers. 2 times 3 is 6. What about 2 to the fifth to the sixth? 2 to the 30th. Absolutely. We good? What about x to the 1/2 raised to the third power? Close. We just want to leave it as a fraction. 3/2, right? Because if I have 1/2 times 3, isn't that really 3/1? And when I multiply fractions, I just multiply straight across the numerator and straight across the denominator. Okay? Any questions about that? Can I make sure you understand why this rule is true? Then let's go back to this example right here. Okay? You don't have to write this part down. I'm just writing it down for you to see. If you understand the rule, just shh for a second. Okay? Hurry, hurry. Okay. X squared to the third. What does that mean, actually? I mean, I have this thing 3 times, right? I have x squared times x squared times x squared, right? Well, what does the product of powers rule say? If I'm multiplying like bases, what do I do with the exponents? What's 2 plus 2 plus 2? Do you want to have to do this every time? Do you want to have to write 2 to the 5th 6 times just so you can add the exponents? So that's why we have this other rule of power of powers. It's kind of a shortcut of this rule right here. Does that make sense? Okay. Next rule. Power of a product. Power of a product. So if I have A, B, so a product being raised to a power, what exactly is being raised to the power? The A and the B, right? So A to the n, B to the n. Both of them are being raised to the n power, aren't they? Okay. Take some specific notes about power of a product. What if I have AB squared? What does that simplify to? Perfect. A squared, B squared. What if I try to trick you? I know that's your favorite thing when I do that. But at least I warn you, right? Okay. X squared, y to the third, raised to the fourth. So I was not successful that time, was I, in tricking you? Even though you had to use other exponent rules, didn't you? You had to use power of powers, didn't you? You had to remember that you multiplied those, didn't you? Okay, can I try one more time? Okay. 2xy to the fifth to the third. So this time I tricked you. This time I did. You're on the right track. Guys, is it 2 times 3? Or is it 2 to the third power. What is 2 to the third power? 8, right? 2 times 2 times 2. Well, 2 times 2 is 4. 4 times 2 is 8. Okay? So sometimes people totally forget to raise a whole number to that power, and sometimes they multiply these two numbers instead of being raised to a power. Does that make sense? So now the good part is you're not going to let yourself be tricked again, are you? Okay? So 8x to the third, y to the 15th. Very good. Okay? What about this example? AB to the 2/3 power. A to the 2/3, B to the 2/3. Perfect. 16. A to the 5th, B raised to the 1/2 power. You said you weren't going to let yourself be tricked by this again. Is it 16 times a half? It's 16 raised to the 1/2 power, right? Now, I'm going to tell you right now, this is something I was supposed to teach you in last chapter. I did not. It didn't fit. It fits right now. So I'm going to teach it to you right now. Okay? When you raise something to a fractional exponent, like this is, also called a rational exponent, the numerator is the power, the denominator is the root. So if I raise something to the 1/2 power, what am I actually doing to it? I'm taking the square root. 1 is the power, bottom is the root, right? 2 is the root, a square root. Guys, what's the square root of 16? 4. Now, how many more times do you think we're going to practice that? A lot, so don't worry. Okay? What if it said to the 1/3 power? What is that? Cube root. What about 1/4 power? The 4th root. Yeah. Okay? The numerator is the power. The denominator is the root. Okay? All right. What do I get with A? 5/2. And B? 1/2. Very good. Any questions about that? Okay. Quotient of powers. Can you use your context clues and tell me what this rule looks like? Division, first of all, because it says quotient, right? A fraction. So in the numerator would go a to, well, what does a product of powers look like? A to the m times a to the n. So what is quotient of powers going to look like? Oh, very good. And what's the rule if I'm dividing like bases? What do I do with the exponents? Very good. So a to the m divided by a to the n, that's going to be a to the m minus n. Examples. X to the 5th over x to the 3rd. Because why? So 5 minus 3 is 2, right? Now, do we want to make this easy on ourselves, or do we want to have to start memorizing a bunch of rules? Oh, okay. Easy? Then here's what we're going to do. If I'm given this problem, x to the 3rd over x to the 8th, I'm going to start right here. And I'm going to say 8 minus 3. What's 8 minus 3? 5. But where did I start? In the denominator. So that's where I'm going to leave my answer. Because otherwise, what am I going to end up with? Negative exponents. No. We do have to deal with those in a second. That's some foreshadowing. What about this? x to the 7/3 over x to the 2/3, x to the 5/3. Okay, so far? Can you tell me what the next rule is going to be called based on what we've done so far? Power of a quotient. Very good. Any idea what it might look like? God bless you. It is going to be in parentheses. So a over b raised to the m power. And what is that rule going to look like? A to the m over b to the m. Power of a quotient. Pardon? Okay. So power of a quotient. X over y to the third. X to the third? Yep, over y to the third. 2a to the 6th over b squared, all raised to the 4th power. You promised you wouldn't let yourself be tricked. What do you think? Try again. Why 16? Why is it 16? 2 to the 4th, right? 2, 2, 2, 2. 2 times 2 is 8. Let me try that again. 2 times 2 is 4, times 2 is 8, times 2 is 16. Yes? 16a to the 24th over b to the 8th. X over y raised to the 1/2 power. X to the 1/2 over y to the 1/2. Now, before we go on to the next one, the next rule that we need to talk about, I need to make something clear to you and make sure you've noticed something. On every single one of these pages so far, I've done problems on one side and problems on the other side. What are the difference in those two sides? Fractions, right? What's the difference in the rule for whole numbers versus fractions? Absolutely no difference, right? If I'm supposed to multiply them, I multiply the numbers here, I multiply the numbers here, right? Sorry, if I'm multiplying, I add the exponents here, I add the exponents here. If I'm supposed to multiply, I multiply here, but I also multiply here. It doesn't matter if they're whole numbers versus fractions, does it? Okay? Just making sure that you notice that. Okay? Okay, next general rule. Negative exponents. A to the negative n is going to equal 1 over a to the n. A to the negative n equals 1 over a to the n. Okay? So, examples. X to the negative 3rd power, what does that actually equal? One over x to the 3rd. What if it's 1 over x to the negative fourth? What does that equal? It's just x to the fourth, right? So if you want to think about it in a silly way, which sometimes I do because it helps me remember stuff, right? Where is this negative exponent? It's in the numerator, right? Where does it want to be? It wants to be in the denominator. And when you move it there, it's not sad anymore. It's happy. It's not negative anymore. It's positive. Where is this one? In the denominator, where does it want to be? When you move it there, it's happy. It's not sad anymore. Is that goofy? Yes, I told you that at the beginning, right? But will it help you remember? Hopefully. But don't let yourself be tricked. God bless you. What's the only thing that's unhappy here? Only the exponents, right? Only the y. Is the negative 2 happy? Yeah, it doesn't have a negative exponent. God bless you. So it stays where it was. What about the x? It's also happy. It's fine where it was. The only thing that's unhappy is the y. And when you move it to the denominator, now it's happy. God bless you. Sorry about that. Got it? Okay. So what's going to go over here then? Okay, so x to the negative 1/2. Where is it? Where does it want to be? If I move it to the denominator, now it's happy. One over x to the negative 3/4 power. Where is it? Denominator. Where does it want to be? When you move it to the numerator, happy. We're on our last tab, right? Last tab at the bottom. Other cool exponent stuff. No, it's not clickbait. It's real cool exponent stuff. Okay? Now, this first thing is what we talked about a second ago. I just want it in writing on your foldable. Okay? A to the m over n power. What did I say the numerator of a rational exponent was? The power. What is the denominator of a rational exponent? The root. Okay? So if I say a to the 1/2 power, what does that actually equal? The square root of a. If I say a to the 2/3 power, what does that actually equal? Well, it's a cube root, right? The cube root of what? A squared. Again, we're going to have some practice on this, so please don't panic, because after all, that is rule number 1. Okay? Now there's a couple definitions that I need you to know. Okay? First definition is this. X to the first power, what does that equal? Always? Yes? And I need you to know this one. Anything to the 0 power is what? 1. Can I show you why? We're going to draw some pictures. Okay? I'm going to come over here to the side. We still have all this room over here. I'm going to come over here to the side and I'm going to draw you some pictures. And I hope that showing you this will help you What is it doing? Okay. I hope showing you this will help understand why this is true and help you remember it as well. Okay? Now, you told me, or you go ahead and tell me right now, what does 2 to the first power actually equal? 2, because you told me that anything to the first power is itself, right? So I'm going to draw you a picture of 2. Doesn't that represent 2? Well, what would 2 squared look like? Wouldn't it look like this? Wouldn't that be 4? Well, what about 2 to the third? What would that look like? Wouldn't it look like that? Isn't 2 to the third equal 8? What about 2 to the fourth? What would that look like? Isn't that 16? These are all definitions we've talked about already in examples today, right? So we know that this is true. I'm not just making this up, right? So just looking at what we've drawn so far, there's at least 4 patterns that stand out to me. At least. I could probably find more if I looked. Okay? Do you see any patterns? What pattern do you see? So 1, 2, 3, 4. Is that a pattern? Could we draw 2 to the fifth if I wanted to? Yeah. But it's just, the exponents are going up by 1, aren't they? Okay. Anybody else see any other patterns? What about from here to here to here to here? Multiplying by 2, right? To get from here to here to here to here, we multiply all those by 2, right? Just to get to the next step. Could I go backwards? What would I do to go backwards? Divide by 2. Okay. The last pattern specifically, well, I guess there's 2 more that I want you to see. And one of them really we talked about before. If I could go up by 1 going this way, couldn't I go down by 1 coming back this way? All right. And the last pattern I want you to see is the actual shape that we drew. What shape is this? It's a rectangle. What shape is this? So rectangle, square, rectangle, square. What's the next shape going to be, even though I haven't drawn it yet? A rectangle. Everybody okay with that? So the next thing I want to do is go here, because that's what we're trying to figure out, right? Well, does it follow this pattern while I decrease by 1? What pattern would happen here? Divide by 2. If I divide that by 2, what should this be? Does that still follow the shape pattern? Square, rectangle, square, rectangle, square. Now I chose 2. Why did I choose 2 to be my base? It's the easiest, right? I could do this with 3 or 4 or 5. Those would get ugly really fast though, wouldn't they? Okay, but wouldn't they be the same? So any power that I get here, or any base that I get here, if I raise it to the 0 power, I'm going to get 1. Let's go another step though. What if I went down 1 more in my exponent? What shape should this be? It should be a what? A rectangle? Does that fit with this pattern over here? Does that fit with our negative exponent rules? This is in the numerator and it doesn't want to be. When I move it to the denominator, what does it become? 1 over 2 to the first, which is 1 over 2. And I want to go one more step. 2 to the negative 2. What shape should it be? Should be a square. Following the dividing pattern, what should it be? 1/4. Does that follow our exponent rule about negative exponents? Where is it? In the numerator, where does it want to be? When I move it down there, I get 1/2 to the second power. Well, 2 to the second power is 4. Does that make sense? Do you understand why 2 to the 0 power is 1? Do you understand why anything to the 0 power is 1? Because it follows all these patterns right here. Does that help a little bit? Okay. So you have this exponent foldable, which you can absolutely use on your homework. Okay. Under one condition. Has your name on the back. Okay. Please make sure your name is on the back, not my name. Hopefully you didn't write my name. Okay. Are there any questions about exponent rules?